Hi everyone, today I'm going to show you how I used Arena simulation software to analyze and improve my project, which is a family doctor clinic. So my goal is pretty simple, which is find a way how can I make this clinic more efficient without hurting the quality of patient care of the family doctor clinic. So first of all, I want to show you how the system is looking like in real life. First of all, we're having here a door which patient can get into the clinic. They will first of all arrive to this queue machine. They have to enter their ID in order to get a queue number and assigned doctor. And then after getting these informations, they'll be waiting in the shared waiting area until their assigned doctors are calling. And basically here, the queue in the after taking a queue number is basically following first in, first served principle. So first patients, if they will arrive here first, they'll be served first. And then after getting the service, they will basically exit the system. To understand the system more, I basically drawed here a real life and systematic view where you can see here all of these are happening in real life, and these are things that we used in Arena software in order to do the same thing as happening in real life, in order to simulate what is happening. So first of all, as I told you before, patient is entering the clinic, takes a queue number, and then they'll be heading to the shared waiting area. And there is a problem here, which is waiting area is shared for all doctors. So when a patient's sit at any place, you cannot know that this person is waiting for doctor 3 or doctor 1 or wherever. So that was a problem that I was facing when I was observing the system. And then after getting their service, they'll be leaving the clinic. So patients in Arena are entities, which I have here, which is patient arrival. This is an entity. And then there's assign one. In assign one, I basically have a attribute which will calculate the time this patients get into our system at this specific time, and then I'll use the same attribute and record in order to get how much each patient spent time at the clinic. And then the queue machine, this is a process. This is our first process, which is working. There were no latency at all when I was observing the clinic. And then since there is a road, which patients are basically going through in order to go to the waiting area, I did add a road. I added a road which have a minute kind of, and then we have a station one and a sign two. A sign two is very important because when patients are arriving, there's two type of patients are arriving into our system. They can be normal people and they can be urgent kind of. When I say urgent, you can think about older people. So in this assigned to, I have two attributes, which is like saying if this patient is urgent, so it'll not wait in a queue after taking the queue number. It will go to the shared area, and they will be called by a doctor right away. They will not be waiting. And then the next process, which is doctor service, and then following a route. When they get their service, they're going out and passing by the shared waiting area until they find the door and dispose. So record here, record one, as I told you, I used it to calculate how much each patient was spending time in the clinic. Okay, so let's start with the initial model. This represents the clinic as it is today. And here we will start with the patient arrival. Patients will start arriving our system here. And after putting the enter arrival time column in input analyzer, what I get is patients arrive roughly through 3.8 minutes. And After that, they'll be checking at the first process, which is queue machine, and then station and route logic are used here, and then going to the doctor service, following a route and station logic also, and then record how much each patient spent time at the clinic. So when I run the first model, the results are following. So what I basically did is I run the model. I can show the setup here. I did use 10 replications, 24-hour, 1 day, 8 hours, as it is starting from 8:30 to 5:30, and then systems closing. This is how I run it. So to save time, I'm showing you here the output as seen 9 hours. So I run it for 10 replications to get rid of these insufficiencies. When you go very down, you'll find here. So here you'll find that I had a 155 patients, which is coming to my system, and this is the number they get out, like nearly the same. And then for Dr. 1, schedule utilization is nearly 36%, and Dr. 2, 23%, and Dr. 3 is 12%. So as seen, Dr. 3 is working less as the others. This is all for the initial model. So as I told you, in our initial model, we have 3 doctors, and the third doctor was not working good enough, let's say. And the clinic is basically paying more for a lot of persons where we can try. So I decided to basically go to the resource set. So what I basically did is deleted the Doctor 3 from the data definition. When you click on data definition and then click on resources, you'll be able to delete the column 3. You will click and delete row. And also from sets, I had a doctor sets, which has 3 rows. I had to also delete Doctor 3 from here, which is same. I'm not going to delete because I have another model file for the improved. I have another file. So after doing these updates, this is the another one. I can show you that in this files, which is the improved version, this is the set having 2 rows, and this is the resource having only 2 doctors. After running the improved model for the clinic, again, I used 10 replications to get rid of insufficient data. I'll be moving very down. As you can see here, number getting in and number getting out. Okay, we're near. Before we were having 144, and here we're having 141. Nearly the same. This system is served by 2 doctors only. And let's check utilization. For Dr. 1, 40%, and for Dr. 2, 28%. And Dr. 3, as I told you, is removed. Let's check here. Dr. 1 utilization is 41% nearly. And Dr. here utilization is 35. It's being more. And Dr. 2, 23, and here it is being 28. So I decided to keep this improvement since utilization is being better of the model, and this way the clinic is not paying more for person who is not working sufficient. Thank you for listening.